In this video, I'm going over the Mock 3 review. So here with 1, 2, and 3, all we're doing is factoring. That's it. So like looking at number 1, always check, see how we have 3 here? Check to see first if we have a GCF, which in this case we do. We have a GCF of 3. So we're going to divide every term by 3. Now I've got x squared minus 6x from the negative 18 divided by 3 plus 8. Now that here x squared is by itself, we can factor, but don't forget the GCF of 3. Now, as we go through, what numbers multiply to get positive 8 and add to get negative 6? Now, again, we're multiplying to get a positive, so signs have to be the same, but adding to get a negative, so they're going to both be negative. And those two factors are 4 and 2. So notice here, that's why the answer is B. So now question number 2. We have the 2 here. So do we have a GCF? No. So we need to start bottoms up. Now we've got x squared plus 13x, but now plus 36. Now that we've got x squared by itself, we'll start factoring. Notice how both signs are positive. And what numbers multiply to get 36 and add to get 13? We'll use the answer choices as a guide too, right? So 9 and 4. Now remember with bottoms up, whatever our A term was, right, that we multiply, we now need to divide by 2. So can we simplify 9 over 2? No, so bring the bottom up. So now we've got 2x plus 9, and can we simplify 4 over 2? Yes, 2x plus 2. So that's why here the answer is D. Now question number 3. Notice here we have our 3 here in front. So we have a GCF. We can divide both terms by 3. So let's take care of our GCF. Now you've got x squared minus 16. Now notice this was our difference of two perfect squares. We have no x term, but take the square root. So here we've got 4. So x plus 4 times x minus 4 with the GCF. That's why the answer here is A. So now going into questions starting with number 4, we are solving. But remember when solving quadratics, and we do have our x term, quadratics always have to equal 0. So notice how we have two terms here. So I'm going to subtract the 8x from both sides. But I'm also going to add 1. And notice here, lining up your like terms, right? X terms with x terms, and our constants here with a constant, number with number. So now in combining like terms, we're going to bring down 7x squared, but now here, negative 15 minus 8, negative 23x plus 6. Now we can go through and start solving by factoring. However, do we have a GCF? Because I see this 7 here, right? So do we have a GCF? No. So bottoms up. X squared minus 23x plus 42 is equal to 0. Now we'll start our factoring. Here again, notice the signs. The signs, well, I'm multiplying to get a positive, so the signs have to be the same. But we're adding to get a negative, so again, both signs have to be negative. So coming up with factors here of 42, we'll start with dividing, right? Can I divide 42 by 2? Yes. If you divide 42 by 2, you get 21. And do these add to 23? Yes, but because they're both negative, right, to get negative 23, negative 2, negative 21. Now, are we done? No. So now remember, right, whatever where A was, whatever you multiply by, now we need to divide by 7. So can we simplify? No. So here I've got 7x minus 2. Then here, can we simplify? Yes. 2x minus 3 is equal to 0. Remember, we're solving, right? Equal to 0. So I can already see that one of my solutions is x is equal to not negative 3, right, but positive 3. So I can already tell that my answer is B. But also go with our fraction here and positive 2 7. So now in number 5, this is one of our special cases. So see how all group together and raising to a power. So we need to first take the square root. Now we've got x minus 8, so we're just bringing that down because it cancels out, is equal to plus and minus 5, so square root of 25. Now we set up our two equations here. X minus 8 is, yes, equal to 5, but x minus 8 is also equal to what? Negative 5. So now when you solve, we're going to add 8 here now to both sides, and add 8 again to both sides of this equation as well. So that's how you get x is equal to 13 as one of the solutions. So I'll cross out b and d. And x is equal to, watch your signs. This gives you positive 3. So that's why here the answer is A. Now question number 6. Notice here we have x times x plus 2. So we need to first multiply and distribute. So x times x is x squared. And 2 times x is 2x is equal to 15. Now here we are solving a quadratic. We have the x term, but quadratics always have to equal 0. So that's why we need to subtract the 15 now from both sides. X squared plus 2x minus 15. And now we can start solving. So here, focusing on factors of 15. Now notice you're multiplying to get a negative. Because of getting a negative, the signs must be different. So factors of 15 that are going to combine to get you 2. 5 and 3, right? But positive 5 and negative 3. Now here, because we're solving, x is not equal to positive 5, negative 3, right? Negative 5, positive 3. That's why the answer is A. Then here, we're solving again. I notice we're already equal to 0, so we're good. We have our x term, so not a special case. We have a 2 here. So do we have a GCF? Can we divide all 3 terms? Yes, we can divide all 3 terms by 2, right? So taking that out, I've got x squared plus 18x plus 80 is equal to 0. Now we can go through and start factoring because x squared is now by itself. Notice how both signs are positive. And what numbers multiply to get 80 and add to get 18? 10 and 8. But again, right, we're solving. So will 2 ever equal 0? No. That's why 2 is not a solution. However, not positive 10, positive 8, but negative 10 and negative 8. That's why the answer is B. So now going into number 8 and 9. So 8 is asking just for the number of solutions. So keep in mind with the number of solutions, that is just figuring out what is the discriminant, b squared minus 4ac. So here's my a, b, and c value. So here we go, b squared, which is negative 5, minus 4 times a times c. Well, a is 3, c is negative 11. So when you solve here, you get a discriminant of 147. Now this is positive, so that means how many solutions? We have 2 real solutions. And so now looking here at number 9, I'm already noticing that we're going to end up having to use quadratic formula here. Now, even with quadratic formula, because we're still solving a quadratic, quadratics always have to equal 0. So what do we have to do first? Subtract the 14 and combining your like terms here. So 2x squared plus 9x now plus 1. Now we'll go through and get our discriminant again, right? B squared minus 4 times a times c. So a, b, and c. So here we go. B squared, which is 9 squared, minus 4 times a, which is 2, times c, which is 1. So when we calculate our discriminant, we get 73. So that is what's inside of the radical, because we're using quadratic formula. I'm going to go ahead and cross out already a and b. Now remember, quadratic formula is negative b plus or minus the square root of our discriminant, b squared minus 4ac, all divided by 2 times a. So here, remember that trick of this is negative b. So negative, what is b? 9. plus or minus the square root of 73, our discriminant, over 2 times a, or 2 times 2. So notice here, we don't cancel out the negative. This is negative 9 over 4. So that's why the answer is C. So now question number 10. Now notice there is no x term. So we are back to our special case where we're just going to solve by taking the square root. So I'm going to go ahead and add 12, right? Because that's the inverse opposite. 7x squared is now equal to 70. But we can't take the square root yet because x is still being multiplied by 7. So now divide by 7. And x squared is equal to 10. Now be careful because people just want to say the answer is C, right? Don't, because now what do we have to do? To get rid of here, our x squared. Take the square root. That's why the answer is D. So now numbers 11 and then 12. Notice we're talking about a real world situation in terms of our quadratic. And we want to know for the diver here, approximately how long is the diver underwater? So here you need to graph this in Desmos, and this is how the graph looks. Now notice a little different, but like what it said, the diver is underwater. So here in the negative, does it make sense to include this? No. So remember, it's like that reasonable domain. So the diver went down and then went back up to the surface of the water. So how long was he underwater? For 6 seconds. That's how long before the diver came up to the water. So that's why here the answer is C. And so now our next situation is about a rocket being fired into the air from a platform. Here's our quadratic that represents the situation. So now the first part is how long again was the rocket in the air, right? So how long before the rocket hits the ground? Then the next part is how high up off the ground. So this is your y-intercept. So approximately how long is the rocket in the air? So here's the graph. Remember, right, we're starting here, it goes up, and then boom, it lands here. So how long before it hits the ground? 4 seconds. Now, high up off the ground is the platform. So remember here, right? How high? Well, the path started here at the y-intercept of 0, 12. So that's why here it started at 12 feet. So now the last portion of the review is focusing on our radicals and the rational exponents. So now here for the first one, notice the difference, right, between 13 and 14. So like, for example, 13, you have a negative exponent. So when the exponent's negative, we are going to have a fraction answer. So we need to flip or reciprocate the base. So now it's 1 over h to the g over 5. Now we rewrite this. So here we go. What goes inside of the radical? H to the g. Oops, sorry about that. H to the g. And then inside of, what's our index? 5. So the fifth root of h to the g. Now notice here, the negative is on the outside. So this just means that this is a negative value here. So if negative, like it's a -1, then it's going to be negative y to the 13th, right? Keep it all together. But now over what? Well, what's the index? 4. So that is what this represents here. So now question 15. We just have to remember when multiplying, right? We are going to add the exponents. However, we have 2 square roots. So what is the index understood to be when we have square roots? A 2. So really, when we rewrite this, yes, this is y to the 5th, but y to the 5th not over 1, right? Over 2 times y to the 15th over 2. So now what do we do with the exponents? We add them, right? Don't multiply, add them. So this is y to the 20 over 2, which simplifies to 10. So that's why here the answer is B. So now question 16. Notice here we are multiplying, but can we do anything? No, because the bases are different. So we cannot add the exponents because this has a base of A and this has a base of B. However, we do have A and B. So we're now dividing. So remember when dividing, top to bottom, subtract the exponents. But remember, the bases must be the same. So see how A is here and here. So to find now the new exponent for A, top to bottom. So this is 3 minus 7, which gives you not 4 because that's 3 take away 7, negative 4. Now we can focus on our base of B. So this is B, the 1/7 minus negative 3/7. So notice, right, write it out so you can see. Notice how here we're going to end up adding them together. So this is B to the 4/7. But then notice, right, are we done? No, because we have a negative exponent, which means we need a fraction answer. So when we have our fraction, what's going to now go in the bottom, in the denominator? A, because of the negative exponent. So A to the 4th and B to the 4/7 power stays. That's why the answer here is A. And then question 17, what is the value of Y? So it's just asking for what is the new exponent, if you notice here. But first we need to rewrite. So here we go. Well, that's just F to the 2nd power, but over what? 5. Now notice we do have in the denominator power to a power. What did that mean? Like think about parentheses, right? Multiply. So that is 3 times 1/5, which is 3/5. So now here we go. We're dividing, bases are the same. So now what do we do with the exponents top to bottom? Subtract. So this is 2/5 minus 3/5, which gives you negative 1/5. That's why the answer is D. Then same thing here, right? We're multiplying, so we're going to add the exponents, but the bases must be the same. So notice how here, what are the two exponents we're going to add? The negative 2/11 and 7/11. Why? Because these are the two bases that are the same. So we're just going to bring down R because that is the only base of R. Then times, now we add the exponents. Negative 2/11 plus 7/11, 5/11. Now, can we combine and say 8/11? No, because the bases are different. So this is the final answer.